Hello guys, welcome to today's leetcode challenge. Today we're going to solve this problem, MinStack. You're asked to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Okay, so this is the instruction. Implement the MinStack class, which initialize the stack object, can also push the elements and all these things. You must implement a solution with O of 1 time complexity for each function. So for example, the input is this MinStack push, 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 and all those stuff. And you can see it was initialized to an empty string, and then after pushing a value, it was added there. After pushing another value, it was added. After pushing, it was added. And yeah, get min, pop, top. Oh, okay, this is the response, the output. After pushing, null, 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 because it is a void. But in the get min, now we have -3, which is the minimum value, and pop, null, top. Get the top element of the stack, so 0. Okay, get min now becomes -2 because it was popped. Okay, so explanation here. So it was initialized, and then a value was added, push, and then push 0. Oh, I see. Yeah, then we pushed -3, and then we pushed we retrieved the minimum value, then we popped it. After popping it, -3 was returned, was removed from the stack, and now the top value is 0 and get min. So here are the constraints. Methods pop, top, and get min operations will always be called on non-empty stacks. Okay, so this is it. We can start writing the implementation. So the idea, okay, we are asked to implement this one, which is pretty much easy because yeah, it's just implementing it. Okay, this is what I will do here. Let me zoom a little bit. So we have an init. We can start by initializing the stack. I can say self.stack is equals to an empty array, and also because we need to also have a way of returning the minimum value, we could also create another stack for getting the minimum values at each go. So for example, I can call it MinStack is equals to an empty array. So at the point of pushing, I want to be adding to the stack, and if the value at the minimum stack is less than the value or is greater than the value, then we update it. So I have two variables here, so that retrieving the value get min should take of 1, and retrieving the top should take of 1 too. So this in the initialization, self.stack is equals to this. In the push, it's pretty much easy. Self.stack.append val, and also we need to append here if it's empty. So if not, self.minStack stack, or the value is less than self.minStack -1. This is the last element in the array. If not, self.minStack or value is less than this one, we need to we need to append self.minStack .append val. So this is it for the push. For the pop is basically removing the last element from the array, or so they have already said that they'll make sure that the methods pop, top, and get min operations will always be carried on an empty stack. So of course we can add a check first, but since they have already told us the constraints, we can go ahead. Self.stack.pop. Yeah, and it is we are not returning anything because we're turning none, so no worries. Okay, we want to make sure that the value that we are popping at the stack is not, we should also pop it in the min stack. So in that case, I will say popped value is equals to step, yeah, this way, and then if popped is equals to self.stack self.minStack -1, I want to pop it to self.minStack of dot pop this way. So to get the top value, it's much easier. So we just get the last element in the stack. So I will do this. And to get the minimum value, of course, we are tracking it here. You can see in the point of pushing, we are checking if it is empty, we append it, or if the value is less than the minimum value in the stack, we append it. So in this case, I will say self.minStack. Here's where we are using the minStack -1. Yeah, so let me proof check again. In the push, we are appending to the stack, which is okay, and also we are appending the minimum value, making sure that the minimum value is the one that is appended here. And in the pop, we are popping the value, and also we are popping the popped value from the min stack if it is the smallest element. And in the top, we are getting the first value in the stack, and in the minimum, we are getting the first value in the min stack. So this should run. I will try to, okay, let me zoom a little bit. Okay, I'm unable to zoom it. Okay, let me run it. Okay, wrong answer. So output null. Why? Get min is returning null. It's weird. Okay. Oh, I see. So see where the issue was. In the top, we are expected to return an int, and I haven't returned it here, so I will update it to return. Same to the get min, it should return the minimum. Yeah, I think this is where it messed up. If I run it, yeah, as you can see, it's running pretty fine, and also if I submit, it should work. Do this. Okay, so in this case, they lied to us that they lied to us that the value will be called on non-empty. So in this case, we need to check if not self.minStack. We need to, if it is an empty array, we just need to return 0 or -1. I don't know. Same to this, if not self.stack, we just need to return -1. Yeah, same to this value in the pop. If not self.stack, we just need to return Let me do the same to this one. This one is okay, and this. Okay, I just resubmitted it and it worked. After updating this to less or is equals to this value. Oh, I see. Yeah, after updating this one, now it is working. See, the program is running and it is running pretty fine. That is it. Thank you. Hey, big.